Good morning, students. How are you? Today we're going to learn how to do a frequency table via a movie, and we have a beautiful data set. You notice the rows are in sets of 10, and we have 25 data points. So our starting lower limit is 0, our width is 0.3, n is 25, and this is supposed to be 7 classes. I scribbled it out. So we want to construct a frequency table, and those are the first 2 columns that you typically see. So let's get with the program. We're going to start out with lower limit 1, which is 0. Okay, and that's always going to be given. Then lower limit 2 is equal to lower limit 1 plus the width. And that's going to be 0.0 plus 0.3, which is 0.3. Then lower limit 3 is lower limit 2 plus the width, and that's going to be 0.3 plus 0.3 equals 0.6. Lower limit 4 is lower limit 3 plus the width, and that's going to be 0.6 plus 0.3, which is 0.9. Lower limit 5 is lower limit 4 plus the width. How are we running for space? Do we have lots of space? Good. I'm talking to my nice friend in the TTLC who always helps me. So we have 0.9 plus 1.3 is 1.2. And that's going to be lower limit 6. And that's going to be lower limit 5 plus the width. And that's 1.2 plus 0.3, which is 1.5. Then lower limit 7 is lower limit 6 plus the width. And that's going to be 1.5 plus 0.3, which is 1.8. And you always need to produce an extra one. You'll see why in a moment. So it's going to be, in this case, lower limit 7 plus the width. And that's going to be 1.8 plus 0.3, which is 2.1. Okay. Everybody happy with this? Good. So let's change pages. This is going to be a long one. Okay. So now we can start setting up our frequency table. We have class. Yes, we do. We have frequencies. We have cumulative frequency, relative frequency, and cumulative relative frequency. I'll do them all out while I do our table. So you start out with 0.0 and under 0.3, 0.3 and under 0.6, 0.6 and under 0.9, 0.9 and under 1.2, 1.2 and under 1.5, 1.5 and under 1.8, and then our last one, 1.8 and under 2.1. That's where you pick up that last one. Okay, now the frequencies, you have to go back to the data points themselves, and this is very interesting. Now notice we have 0.3 and it's under that. So our first row, we will include all of those. So there's 10 in the first row. We will not include the 0.3 in this one. So we have 10 as our frequency. Now, where's my little, here we go. Then we have from 0.3 to 0.6. Notice again, you're going to include the 0.3. You don't include the 0.6 here. So you have 1. Then 0.6 through 0.9 is 5. 0.9 and under 1.2 is 4. Then in the next class, 1.2 under 1.5, there are no values in there. Go ahead and leave that line in there and just put a 0 in. Don't strike the class from there. So then we have 1.5 through 1.8, and that's 2, and 1.8 through 2.1, which is 3. Now what I like to do, just for my own self, is add up and see if this is equal to the sample size. So we have 10 plus 1, which is 11, plus 6, which is 16, plus 4, which is 20, 22, and 25, which is as it should be. That way, if you've made a mistake there, you can clean it up right away. Now, cumulative frequency, we're going to use what I call the cheap and sleazy method. So we're going to start by writing the 10 again. And what we'll do to get the rest of the values, you're going to zig and zag across. So you have 10 plus 1 equals 11. 11 plus 5 is 16. 16 plus 4 is 20. 20 plus 0 is still 20. 20 plus 2 is 22. And 22 plus 3 is 25. Now that last number down there must always equal the sample size, and it does, so we're safe. Relative frequency is nice and straightforward. It's just the frequency over the n. So it's going to be 10 over 25, which is 0.4. Then we're going to have 1 over 25, which is 0.04. Watch your decimals on these. 5 over 25, which is 0.20. 4 over 25, which is 0.16. 0 again. 2 over 25, which is 0.8. It's my fault. 0.08. Watch your decimals. Don't be like me. 3 over 25, which is 0.12. Okay. Now, let me put the 0. Okay. Let's do our cumulative relative frequency, and we have a cheap and sleazy method here. You recopy the first one over from relative frequency, and you start zigging and zagging. So you have 0.40 plus 0.04 gives me 0.44. Then plus 0.20 gives me 0.64. Plus 0.16 gives me 0.80. We still have that 0, so it stays at 0.80. 80 plus 0.08 is 0.88. And finally, 0.88 plus 0.12 gives me 1, and you always want to have 1 in the last column. Okay, good. Thanks for listening. Bye. Good morning again, student people. Here's yet another beautiful data set, and we're going to practice some of our means and medians and such. So when you read down through the questions, you'll notice we need median and mid-range and range and things. So what I'm going to do is start out by sorting the data and putting it into columns. So let's change pages. And we're going to have x of 15, 15, 18, 18, 19, 20, and 24. And when I add those up, that gives me the summation of x, and that's equal to 129. Now we're going to need the summation of the x's squared in a minute, so let's go ahead and generate those. So you're going to have 15 squared, which is 225. I'll have another 225. 18 squared, which is 324. Another 324. And then we'll have 361 and 400 and 576. When we add these up, that's the summation of the x's squared that we'll need for our variance. That's 2435. Okay. So now we can get our mean we know that's going to be the here's your x bar, equal to 129 over 7, and that's going to give me 18.43. For the median, we'll do our usual scratch and sniff method. Scratch the first one, the last one. Second, second to last. Third, third to last. And we're left with 18. So you have an x median of 18. The mid-range, you're going to take the smallest value, which is 15, plus the largest value, which is 24, add them up and divide by 2. That gives me 39 over 2, or 18.5. Whee! Isn't this fun? Okay, then the range is the big one minus the small one, and that's going to be 24 minus 15, or 9. Now, make sure you understand the difference between these two, because they get to be a little tricky, so just be aware of the differences in the formula. Okay, now let's go ahead and put together our variance. So, we need a nice clean sheet of paper. So we're going to have s squared, that's equal to 2435 minus the 129 squared over 7, the whole thing over 7 minus 1. And that's going to be 2435 minus, oh wait, where's my other page? Time to panic. There it is. Okay, 16641 over 7, the whole thing over 6. And that's going to be 2435 minus 2377.29 over 6. That's going to give me 57.71 over 6, which will give me 9.62. Okay, and then our favorite one, our sample standard deviation, is just the square root of that. So it's going to be the square root of 9.16. And before you can say miniature schnauzer, you have 3.10. Okay, great. Thanks for listening.